Okay, one more video, and this should wrap up solving simple exponential equations with logarithms. So I'm looking at 2 times e to the negative 6 phi minus 2 plus 6 equals 8. So remember your first step, combine like terms. Okay, so we're going to combine like terms. And when I say like terms, what I mean is anything that looks similar. So that could be whole numbers. It could be fractions with variables in them. You know, you just get everything to one side. So we subtract 6 on both sides, and we get 2e to the negative 6 phi minus 2 equals 2. And now we divide each side by 2. Okay, so this becomes e to the negative 6 phi minus 2 equals 1. And at this point, the logarithm is isolated. The exponential is isolated. So it's time for step 2. Apply a log to both sides. And this step doesn't specify what the base of the log is, but it usually makes sense looking at the equation. Okay, in this case, because e is the base of the exponential, I'm going to use a logarithm with the same base. So that's log base e, which we know as the natural log. Okay, so let's do that over here. I'm going to say the natural log of e to the negative 6 phi minus 2 equals the natural log of 1. Well, this one's going to simplify a little more than usual, because the natural log of 1, like any log of 1, log of any base b, whether that's e or 10 or whatever, let me mess this up. The log of anything, any base of 1 is always equal to 0. Because if you think about it, what that's saying is b to the 0th power equals 1, which is always true. So this side over here is actually just 0. And this side on the left, you can imagine rearranging with the power rule to say negative 6 phi minus 2. Remember the power rule of logarithms says you can take the exponent out and put it into the coefficient multiplier. So now we have negative 6 phi minus 2 times natural log of e equals 0. And what's the natural log of e? Well, remember what natural log is. That's log base e of e. Well, base is equal to the argument, so the answer is always going to be equal to 1. So this right here is just the number 1. So you have negative 6 phi minus 2 equals 0, which means negative 6 phi, the rest solves itself, right? Negative 6 phi equals 2, and that means phi equals negative 2 over 6, which you know is just negative 1/3. Whether or not you write that last part, it's not really necessary. This is your solution. So one more, and I think we'll have covered just about everything we can with these types of equations. So in this one, you see there's a lot going on. I've got exponentials everywhere, and they're not raised to the same power. They're all the same base. That is convenient. So let's just go about this. Remember step 1, combine like terms. So what are my like terms? Well, I can see in all of these things, let's get a different color here for a moment. I can see all of these things have a 2 to some power. Okay, so wouldn't it be nice if we could get all of these together somehow? Let's try it out. First, I'm going to multiply the 4 and the 5 together. That gets 20. Remember, this whole thing is one long string of multiples, so we can multiply them in any order we like. So I have 20, that's 4 times 5, and then I have 2 to the negative 2 omega times 2 to the negative 10 omega on the left. And on the right, we'll just leave this here for a moment. 8 times 2 to the negative 8 omega plus 7. Okay, well, let's keep focusing on the left side. Remember, when you have exponents, this is a property of exponents, a to the m times a to the m equals a to the n plus m. Remember this? This is called the product rule of exponents. Well, we're going to use that over here. And if you look at what the exponents are, it's, let me grab a different color here, it's this negative 2 omega and the negative 10 omega. So rewriting this, you get 20 times 2 to the power of negative 2 omega minus 10 omega, right? We just added them up. And that equals 20 times 2 to the negative 12 omega. And what's on the right side? Well, that hasn't changed. That's still 8 times 2 to the negative 8 omega plus 7. Okay, so this is great. We've got it simplified. One of those terms is gone. I would still love to have one exponential on one side, just combining everything. It's not necessary, but it would be nice. So let's think about how to get this term right here, not the whole thing. Let's think about how to get this term combined with this one over here. So to do that, I'm going to, again, multiply both sides by something. Remember, this is an equation. You can always multiply both sides of an equation by anything you want, as long as it's useful. So I'm going to multiply both sides of this equation by this number, 2 to the 12 omega. Right? Where did I pull that one? We'll see in a moment. And on the right, we have 8 times 2 to the negative 8 omega plus 7. And I have to do the same to both sides, which means this gets a 2 to the 12 omega also. Okay, it looks like I made things worse, right? But look at what's going to happen here. Because I am multiplying these two things together, I'm going to add the exponents. And that makes the left side 20 times 2 to the negative 12 omega plus 12 omega. And on the right side, well, this is going to be 8 times 2 to the negative 8 omega plus 7 plus 12 omega. That exponent's getting to be almost longer than the whole equation. But look at what we've got on the left side. Remember, this is the whole reason I did this thing. Negative 12 omega plus 12 omega gets you this beauty. You get 20 times 2 to the 0. Okay, now on the right, we've got 8 times 2 to the, negative 8 omega plus 12 omega. That's going to be 4 omega plus 7. Now on the left, 2 to the 0 power, remember anything to the 0 power is always just 1. So this right here is just 1. So I get on the left, 20 equals 8 times 2 to the 4 omega plus 7. And now divide each side by 8, and you get 20 over 8 equals, well, let's just simplify that, 5 over 2, I think. 5 over 2 times 2, no, hold on. 5 over 2 was the left side of the equation, and that equals 2 to the 4 omega plus 7. Okay? Now, I have finally isolated the exponential. Now we're ready to apply a logarithm to both sides. And because the base of this exponential is the number 2, I'm going to choose a logarithm of base 2. So I'm going to say log base 2 of 5 halves equals log base 2 of this thing on the right, 2 to the power of 4 omega plus 7. Okay, and using the power rule of the power rule of logarithms, I'm going to bring this exponent down as a coefficient. It's going to be 4 omega plus 7. That's going to be in parentheses, times the log base 2 of 2. And that is equal to log base 2 of 5 halves here on the left. Well, log base 2 of 2, we've done this example a few times, that's just equal to 1. So now what I've got is log base 2 of 5 over 2 equals 4 omega plus 7. And now we're basically done. We just need to grab omega by itself. So this is going to be log base 2 of 5 over 2 minus 7 equals 4 omega. And then we just divide each side by 4 and we're through. So that's 1/4 times, you know what, I don't want to write it that way. Just write it this way. I'm going to take log base 2 of 5/2 minus 7, divide the whole thing by 4, and that is omega. And we're done. See, that was a snap.